There we are. Okay guys, we're up and running, alright? So, these are what are called inequalities, and the two things I want you to remember about inequalities is this. Imagine that 16 is bigger than 12. Is everybody alright with that? You're allowed to divide or multiply by any positive number you want. I'll give you an example. What happens when we multiply by 2? 32 is bigger than? Did it make a difference?
No.
The left side is still bigger than the right side. Let's try dividing. Pick a number that will divide into 16 and 12. 4. 4 is bigger than 3. So what we've determined here is that multiplying and dividing by a positive number does not change the inequality. Is that right, you guys? Perfect. Now, another thing. If I had 7/8 is bigger than 5/8, yeah? Does the 8 matter?
No.
What makes it bigger is the 7 compared to the 5. So if I get rid of the two of them, look what happens. 7 is still bigger than 5, yeah? Nothing still matters. Now, another thing we could do is I could say that, imagine that 3/4 is bigger than 6/8. Can I cross off the 8 and the 4?
No.
They're not comparable, are they? So what else could I do? I could get them a common denominator, couldn't I? So what could I do with the 3/4 to turn it into 8s? Am I allowed to do that?
Yeah.
Because basically 6/8 is still 3/4, isn't it?
Yeah.
So I haven't changed anything, have I? No. So in this case they're actually equal to each other, aren't they? So sorry, what I really should have read was probably should have read 5/8. That 6/8 is bigger than 5/8. Okay? Or I could have just done it like this. I could have said instead of greater than, it's greater than or equal to. Is that right, you guys? Now, finally, the most valuable trick in inequalities is the negative sign. So imagine that 6 is bigger than 5. Everybody agree with that? What happens when I multiply both sides by a negative number, as in -1?
Then 5 is bigger. 5 is bigger.
So you have to change around the sign, don't you? When you multiply by a minus number, switch around the sign. Now we're going to begin. I'm going to do question 8 really quickly. 4 times x. 4x minus 8 greater than or equal to 10x minus 5 minus 9. Everybody alright with that so far?
Yeah.
Bring the 10x over so we'll tidy up first. 10x minus 14, 4x minus 8. Everybody cool with that? What's the next part? Bring the 10x to the left and what happens? Minus 10x plus 4x greater than or equal to minus 14 plus 8. And what about after that?
It turns into 38x minus 6x.
Greater than or equal to minus 6. We don't deal with minus in front of the x. Suggest a method to fix that. Multiply by minus 1. And you get 6x is less than or equal to 1. Yeah? And then, sorry, less than or equal to 6. Sorry. And then divide by 6. X is less than or equal to 1. Now what does this mean on a number line? If that's minus 3, minus 2, minus 1, 0, oh sorry, 0, 1 and 2. First of all, is the 1 included? Is equals to 1 allowed? Why is equals to 1 allowed? Why is equals to 1 allowed? Okay, I get it. Alright. This means all the numbers that are smaller than or equal to 1. Everybody get that? Smaller than or equal to 1. So because it's allowed to be equal to 1, you shade in the 1. Because it's x element or, what does that mean?
But they're real numbers.
You're allowed fractions and decimals, yeah? So if it's x element or, you shade it in like this. Everybody happy with that? Cool. x element r, fractions and decimals are included. Now, what would happen if this wasn't x, if there was no equal sign? What would happen then? What do I do to the 1? I use a hollow dot. And what does the hollow dot mean? 1 is not included. You're paying attention to that, everybody? Yeah? Okay. Huh? Hollow dot, if it's not included, and if it is included, full dot. Everybody right with that? Now, what happens if I change this to x element z instead of x element r? What happens now? Anybody remember?
Is that
Just whole numbers, exactly. So what would I do this time?
So you do the dot, except you don't shade in the whole line, so you do dot.
Everybody alright with that? Whole numbers, no fractions or decimals. Okay. What about the everybody knows that x element n means 1 and above, yeah? Means 1, 2, 3, 4, 5, 6, 7. You're not allowed any negative numbers. Everybody okay with that? Alright, we'll move on to the next one. This is just purely for you guys to revise later on, okay? Pretty much the night before the exam, both videos, right? Or before that would be nice as well. It should be like your second or third time going over if you're looking to get over 70, okay? Now, what about this one here? What's the key problem with this one? What's the big change up? Solve the following inequalities and graph your solution on a number line. The fractions are the problem. Any solution to the fractions? Common denominator, which is 10. 2 top, 2 bottom, 5 bottom, 5 top. 6x over 10 minus 5x over 10 less than or equal to 3 over 10. Do the 10s matter? No. 10s do not matter. Then the 10s disappear. What next?
X
Less than or equal to 3. Okay. Ryan, take the lead. Shaded in dot or hollow dot?
it's
Shaded in, why?
because it's including, because it's
Equal to 3. And what do I do now? Do I just put dots or what do I do?
you do the line.
Why did you do the line?
It's including fractions.
It's in x element or? Yeah, including fractions, so. Everybody right with that? Okay. Next type of question you have is what we call the bridged one. Okay, when you see one like this, yeah? This one's important, right? So when you see one like this, here's what I want you to do. I want you to draw a line straight down the middle. And anybody tell me what you do next?
You do the -4.
Now, you do it like this. You either cover up this one, or you cover up that one. So let me explain. I'm going to cover up this side first, yeah? So what inequality do I have? -4 less than or equal to 3x minus 1. Everybody right with that? And then when I bring these over this side, what do I have this time?
3 minus 1 is
So lads, you're going to be seeing that question again soon, so remember, yeah? Now, what do we do next? Bring the 1 over and it becomes -4. And then -3x less than or equal to 3x. We want the, -3 less than 3x. We have a trick, don't we? What's our trick? We want the x to the left and the number to the. So we can do -3x less than or equal to 3. Both sides by -1. And then after that, divide by 3. Everybody right with that? Okay, you'll probably do the practice again in your own time, yeah? Now what's next? The other one, what about this one? 1 over the other side, what happens?
Plus 1.
3x equals 11 plus 1, which is x less than 4. Are we including decimals and fractions?
No.
Why?
Z.
Huh?
Z.
Element z, integers, okay? So what happens next? Minus 2, minus 1, 0, 1, 2, 3, 4. Everybody ready for this?
Yeah.
Is minus 1 included?
Yeah. Oh yeah.
Equal sign means yes. Is 0 included?
Yeah.
1,
Yes.
2,
Yes.
3.
Yes.
Is 4 included?
No. Hollow.
Not hollow, because it's x equals z, so you just don't even bother putting it in. So the answer is all the numbers that are bigger than or equal to minus 1 but are smaller than 4 is minus 1, 0, 1, 2 and 3. Everybody go with that? Now, if I change this to x element r, yeah? If I change this question to x element r, what would happen? First of all, it's no longer dots, is it? It'll be a shaded in line. And what's the next thing what would happen? Is 3.99 smaller than 4?
Yeah.
So that means we'd include this part as well, wouldn't we? No, is 4 included?
No.
So I'd say hollow dot. Is minus 1 included?
Yes.
So I'd say full dot. And that's where you see the full dot versus the hollow dot. Full dot when there's an equal sign in the greater than or equal, and a hollow dot when there's no equal sign. Everybody happy enough with that? Alright. 16 minutes in. Okay, anybody tell me what the goal of this question is? Anybody tell me the goal of this question? Yes, Ryan.
You have to get B by itself.
You have to get B by itself. The whole point is to get B by itself. What's currently stopping B from being on its own?
Fraction.
The fractions. Any idea how to get rid of fractions?
Make it fraction 2 plus C over 2 and D over 2.
So what I think Ryan was telling me there was over 2 and over 2, 2 and over 2.
No.
Huh?
Oh yeah. Yes.
Okay, and what happens to the 2's?
Cancel.
Because they're all the same, aren't they? So then we're left with B plus 2C equals 2A. And what's stopping the B from being on its own?
2C.
So?
Bring that over into 2A minus.
Yeah? You guys found these easy at the time. It's probably just forgot them since then, yeah? Now let's try another one.
Is that it solved?
Yeah. It's solved because B is on its own and all the other numbers on the other side. Okay, what makes this one difficult? What else makes it difficult?
You have to get Q on its own, but it's unknown. There's S and some fraction.
So what would you say if I put a Q below this one? What would that mean?
It's QS. That means
Q above it, yeah?
so you cancel all the Q's on below.
QS equals P plus R.
Get S and then do it above it. Divide by S.
If S is multiplied on the left, it's
Divide. So it's P plus R over S.
good. Okay. I forgot to put down what letter I'm looking for there. Q. Q on this one, yeah? Hector's telling me the same technique. So Hector's saying, why don't you look for Q on its own, yeah? So what Hector's telling me, Aaron, is that Q on the bottom, Q on top, then this side, Q on the bottom, Q on top. Then what do I have? QP plus T equals R Q. I want to get Q on its own, don't I? But how many Q's are there? 2 Q's, yeah? So what can we do this time? Group them. I like that, Oisin, right? So what Oisin's going to advise me to do is bring the T over this side and bring the RQ over the other side, so we get QP minus,
Yeah, and then
or Q minus T. What are you going to tell me, Aaron?
then you do Q bracket.
Yeah.
P minus R.
Q bracket P minus R equals minus T. Then after that, Aaron,
Then you
want the Q on its own. What's stopping the Q from being on its own?
bring it to the other side.
The P minus R. Is it multiply or divide?
It's divide.
It's currently multiply, but it will be divided. See the way there's nothing in between the Q and the P?
It will be divide.
So it'll be divide on the other side, which makes it minus T over
Over
P minus R. Everybody right with that? Another answer to that is, another person might have done this question, and the other person would get this answer here. Are they both correct?
Yeah,
Why?
because it doesn't matter what way they are. Like 6 multiplied by 5 is the same as 5 multiplied by 6.
Sort of like that. This one here, the pink one, is the minus version of the yellow one. If you were to multiply the yellow one top and bottom by minus 1, you'll get the pink one. So the minus versions are also accepted. So there's 2 possible answers. Is that alright? You could get either, and you're both correct. Okay. Now, I think we're good to drive on. I suppose the only one I'd need to look at maybe is 27. And in question 27. Okay, guys. What does it mean by half AT squared? Yeah. Okay, what does it mean by half AT squared? This part here. What does it mean by it? It means whatever AT squared is, half it.
Yeah.
Yeah? Now, what do we need to do next?
Multiply, or do like 80 over 2 by 80 over 2.
Yes, I'm going to call that 2s over 2. I'll call that 2ut over 2. Then what happens, Bill?
2s is equal to 2ut plus 80.
Yeah, so Bill does ignore the 2's. And what letter do you want on its own, Bill?
A.
Want A on its own. So what do we do first?
AT squared is equal to
Yeah.
2s
Yeah.
minus 2ut.
Yeah. And what's stopping the A from being on its own now?
T squared.
The T squared, yeah. So what do we do with the T squared? It's multiply on the right, which means what when it's on the left?
Oh, divide.
Divide. 2s minus 2ut all over
T squared.
T squared equals. Everybody okay with that? You'll need to revise, yeah? Now, these ones. Yeah, we got a little bit of work to do here. Nearly there, guys. 8 minutes. Okay, we're going to get a little bit done here. Now, anybody remember how to do these ones? Anybody at all?
Yeah.
Let's quickly run you through all the rules. Rule number 1. 3 to the power of 2 multiplied by 3 to the power of 4 is what?
3 to the power of 6.
3 to the power of 6. What did you do?
Add them.
He added the 2 of them together. Everybody right with that? What's 3 to the power of 2 to the power of 4?
3 to the power of 8.
3 to the power of 8. What's 3 to the power of 7 divided by 3 to the power of 2?
Yeah.
3 to the power of 5. What's 3 to the power of 0? Or 5 to the power of 0? Or 10 to the power of 0? 1, 1, and 1. Any number to the power of 0 is 1. Just don't think too much about it. I just need you to. We went over it in detail at the time. We haven't got the same time for that detail, so I just want you to remember this time. Okay? Now, other things you got to remember. This will all be here, right? Square root sign. What's root 5? 5 to the power of a half. Everybody cool with that? What's root 7?
7 power half.
It's not 7.5, I mean 7 to the power half. Okay? Just memorize it off. Don't need to remember. Don't need to understand it too much at the moment. Right? Next thing. What's 1 over 5 to the power of 3? Anybody remember this one?
5 minus 3.
5 to the power of?
Negative 3.
Negative 3. What's 1 over x to the power of 5? X to minus 5. If it's a 1 on the top, see the number on the bottom? All you have to do is add a minus. Oh Shane, what's 5 to the power of minus 4? What's it saying as? 1 on top. What's on the bottom? 5 to the power of 4. See the pattern between all of them? 5 to the power minus 4 is 1 over 5 to 4. 5 to the power minus 3 is 1 over 5 to 3. X to the power minus 5, 1 over x5. Okay? Now, I'm going to put all those rules together now. Okay, so brace yourselves. So, step 1. In these questions you're going to get in your Christmas exam, they're not always the same. So there's a button in your calculator that will sort that out for you. Anybody remember the button? Shift. Yeah, so I'm just going to shift fact. So I put 4 into my calculator, yeah? What does 4 turn out to be? Shift fact. To the power of 2. So it's going to be 2 to the power of 2 to the power of x minus 3. Do you see the way I just changed the 4? Didn't change anything else. What can I change 32 into? Shift fact 32 is 2 to the power of 5. What rule do I use on the first one? Do I add or multiply? You multiply. 2 to the power of 2x minus. What do I use for 1 over 2 to the power of 5, Patrick? 2 to the power of negative 5. Anybody know the next step? Yes?
Take off the 2's.
Take off the 2's. If the base numbers are the same, there's no need for anything else. And after this, and you get 1. That's going to be plus 6, isn't it, when you take over the 6? Then x equals half. Yeah? Brilliant. Now, the next one is exactly the same, actually, as it turns out. What can I change 25 to? 5 squared. What can I change 1 over 125 into?
1 divided by 5 over.
Yeah. 1 over 5, 3. 5 negative 3. 5 to the power 2 by x minus 2.
2x 2 minus 1.
Multiply. Then the last part. So 2x minus 4 equals minus 3. 2x equals 1. X equals half. Okay. Going very fast now, unfortunately. Alright guys, I'm going to take out the big one for you. The hardest one in the test. Or one of the hardest ones in the test. I'm going to take out this one for you. Ever see this one? Looks difficult, doesn't it? Alright, here's what we're going to do. 5 to the power 2x plus 3. What's 125? 5 to the power 3 in the factorised button, yeah?
Yeah.
What's 5 to the power of what's root 5?
5 and a half.
5 to the power of a half. What's 5 to the power of 3 divided by 5 to the power of a half? Do I add them, multiply them? I subtract them. What's 3 minus a half?
5 over 5 half.
And most of us are going to do this in our calculator, right? We don't trust ourselves with fractions, yeah? Good. 5 halves. you take the top power minus the bottom power. So you end up with 5 to the power of 5 over 2. Everybody right with that? Now what's the next part?
Get rid of the base.
With the base numbers. 2x plus 3 equals 5 over 2. What's the awkward thing about this? Anything to get rid of the fraction, what can we do? Now what does it become?
4x plus 6 equals
4x plus 6 equals 5. 4x equals 10. So with that, we'll drive on. I probably won't give you a squared version. The only difference between the squared version and this version is that there would be a square on the outside, isn't that correct? And then at this point here there would have been a squared under. And what happens when it's 5 to the power 2 squared? You multiply them, don't you? What's 5 over 2 times 5? 5 to the power 5. 2 times 5 over 2 is 5. I'll probably leave that one out. I'll leave it out. Alright guys, these ones. Question 21. This is the reverse of a reference number. Yeah? The reverse. You start off with the answers and you got to work your way backwards. What's step 1? You're going backwards. I'd say it's x plus 3 equals 0. What about you guys? What's the next step in this one? Equals? What's the next step after that? X plus 3. X minus 5 equals 0. You're making the original quadratic equation.
X squared.
Multiplied out.
X squared.
Yeah. 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 Then after that, what's next? X squared minus 2x minus 15. If you solve this using the reference number, what will happen? They will be your answers. You're just going backwards. Okay? I think we did this before, did we? Going backwards. Alright, let's try one more. Going backwards. 1 second. Yeah, what was it?
When you're writing that down, those questions, you have to do the reference number either way. Like you have to write
No, you don't have to check it. This just means get the original equation. So here's your first answer. And what's your second answer?
2
Over. Alright, what's the second last step before we got this answer? The 2 is now division. What was it before it was division? And what side was it on? 2x equals? And this side?
5x equals.
Okay, the step before that.
5x minus, or 2x plus 1.
Equals?
5x minus 2.
The step before that.
2x plus 1
Remember, this is usually the point at which we say the first bracket equals 0 and the second bracket equals 0. What's the next part after that? And what you get, Aaron? Yeah. Yeah. Plus 5x. After that, x squared. Oh, sorry, 10x squared. All that will appear on your YouTube channel TY 2016-2017. My advice is you go over every single one of them. Another